today, so I'm on a Mac, so things may look a little bit different, but probably mostly the same. Um, it's going to be first person. You could make it appear to be third person by setting it up a little bit differently using the same style of controls. Like if you want to move the camera back and put a model in the view of the camera, you could kind of create like a third person style look if you wanted to. Yeah. But we're not doing like a real like 3D game physics thing. That's like way too complicated. I mean, there's plugins that you can use to just do that if you want to, but in terms of like writing the code, what we're going to do is a lot simpler than that. But I'll explain, today we're just going to work on the controls. I'll explain the physics a bit more next time. Um, so yeah, what we're going to be doing today is basically like half of this pointer lock control example. Um, and I'm going to talk about kind of how it works. We're already on three.js. Controls. I'll just go straight to pointer lock. So yeah, this is this pointer lock example. And basically it's pretty simple, sort of first person 3D scene controller with like really simplified physics. So you can see that I can walk through the boxes. So there's no like collision detection happening. But basically, what it's doing is if the camera is like on top of an object, like it is right now, or if it's on top of the floor, then it's not gonna fall. And if it isn't directly on top of something, then it does fall. So it's a really simple way to create like a, you know, uh, gravity component and a jumping component without having to like implement a very complex physics library. But we're going to focus on today is just the controls because it's going to let us touch on a few different things, both with programming and with three.js that are important to cover as we continue to learn more three.js stuff. Um, so yeah, this is what we're going to be working on. And so I'm going to click on the little brackets to take a look at this example in the code. And I'm going to be rewriting a lot of this in a way that I think will make more sense for you guys, given what I assume you guys learned in MMP 210. I think most of you did not have MMP 210 with me. A couple of you guys did. So I have some sense of what you guys probably learned last semester or whenever you took MMP 210, but I don't know exactly what you learned, so I'm kind of guessing a little bit. But I think I'm gonna try to make it make sense a little bit more in that direction. But as usual, if something doesn't make sense or if you want to try something a different way, just let me know. I am going to create a new copy of my project over here. Since I'm not using Git right now, I'm just going to make a new copy of the project because I am going to do some significant changes here. So this is the project that I'm on. I'm just going to go ahead and click remix on here and create a new version. And so I'll just rename it. Edit project details. Let's call this MMP 310 3JS part 3. Okay, and we'll say we're adding first person camera controls and click save. Um, and so I guess I didn't change this comment for part 2, but let's change it for this one. So let me zoom in a little bit. And so say MMP 310 3JS demo part 3, adding first person controls. And I'm going to put a link to this example. Whoops. Okay. And let's open the preview window so we have that available. And let's get our console open so we can see any errors we might run into. I forget, oh, this is some stuff related to the sky. I should take out these logs. But here's the scene that we have so far. We've got our little grass ground and our tree and our clouds, and then we've got our new rotating duck. And so there's not a ton to explore in this demo scene, but you guys have added a lot more into your own scenes. And so what we're going to do is add some controls in here so we can explore the scene, not from this like top-down omniscient perspective, but from a first-person perspective, which will kind of feel more like a video game, but also just feel more like a cool way to explore a space. Um, so yeah, that's what we're going to work on now. Um, so back in the code, as usual, I need to add in a new script. Let's take a look at what we've got in our code so far. So we've got some variables here. We've got our globals, things that we need to reference, like our scene, our camera, our render, our controls. We're going to keep using this controls variable, but we're going to install some new controls. So I don't have to change anything there. We've got our sky and our sun, and now we've got this duck. And then we have some parameters. We have this ambient color that we're using for the light. I'll probably add some more parameters in here today. And then to start our scene, we initialize the scene, which sets up most of this stuff here. And then we load our scene, which loads in our model, and it also loads in the three.js editor scene. And then once the load scene is done, it calls this onload function. So let's collapse the load function. Once the load function is done, it calls the onload function. This no longer calls the init function because we need access to some of the stuff in there. So we just add the rest of the stuff like the lighting, scenery, and we start the scene by calling the animate function. This really starts the scene. I'm going to put a comment in there. And then I think I have a log in here, so let's get rid of it. Here we are. Let's get rid of that. And I always forget to put these little spaces in here. They're not necessary, but that's how three.js is usually written. So I'll try to use that when I remember. Did I have another log in here? No, okay. So in our init function, we are just creating the scene. We're setting the background color and setting up the camera. And then we're setting up our renderer. And there's some settings in here for the sky that I forgot to add in last time. So these aren't necessary, but if you're looking for those, they're in the init function. And then here's our controls. This is where we're going to spend some more time today. So right now we're just using the default orbit controls. We don't really have to do a whole lot to set those up. So that's our init function. The lighting function obviously sets up the lighting, and now it sets up the sky. And let's get rid of this log here. And then our scenery sets up our scenery. We don't need to review all of that. And then the animate function updates our controls and it rotates our little duck. And we're also going to be adding some more stuff in here to update our new controls that we're going to be adding. So that's a little bit of an overview of what we've done so far. So now we're going to get into adding our new controls. I'm going to start by getting the script, and it's a little harder to find, as we discovered last time, than it used to be. Basically, because of the way that the new version of three.js, the module version, does the imports, it's referencing these kind of like three.js add-ons. But the original like regular JS version is still just inside the examples folder. So to do that, to get that, I'm just going to go to the three.js GitHub. So if I go to 3js.org and click on the GitHub, this takes me to the original, the source code for the library. And most of the like external stuff that isn't part of the main library is available inside the examples. And then we're using regular JS, not the JS modules. So we're going to go to the JS folder and then go to controls. And here's our pointer lock controls. And what that refers to is that when we click on the screen, it kind of locks the mouse into place so that we can move the camera with the mouse. So that's why it's called pointer lock controls. So we just need this script. I'm gonna click on raw to get just the script itself. You can see it's actually not all that long, but it does a lot of stuff for us. And so now I just need to save this. I'm on a Mac today, so I'm just going to hit Command S to save, and it's save that to my downloads folder. If you're on PC, just hit Control S. Um, and now I just have to upload it. So I'm going to go back to my glitch project and open up the side menu and click plus on files, click upload. And here's my pointer lock controls. I'm going to click open. And so it adds it into the main folder. I want to organize it under JavaScript. So I'm going to click on the menu and rename it and put JS at the beginning. This is kind of particular to glitch. So this isn't how most of these services are set up, but that's how it works here. So now I've got my pointer lock controls inside my nice JavaScript folder, and I just have to remember to add it into my index page. So I'm going to click on index.html, and then I'm just going to copy one of these script tags that I've already used and paste it in here. And then I just have to add in pointer lock controls. And let's open this up and just make sure I spelled it right. Pointer lock controls. Okay, so now we've added this new package. So yeah, we can see that we're sort of accumulating these different packages. And then since I'm no longer using the orbit controls, if I want to remove that, I can delete it. I can also comment it out using command / or question mark, just so I don't have to load it into the site. It's not going to make a huge difference, but it'll save a little bit of loading time. So now we've got our pointer lock controls set up, and we can go back to our script.js. And let's collapse this. And so now when we initialize our controls, let's go into the init function here. So now instead of creating these orbit controls, we're just going to change this to pointer lock controls. And that's going to do some stuff out of the box for us, but there's a lot more that we need to do to get this set up. So I'm going to get rid of this little enable zoom here. And so this is already set up decently because we still have the same camera and the same renderer, so we don't have to change these arguments here. But now we're going to have to actually set up our controls. And so we're going to look at how they do it in the example, but I'm going to change a couple things to simplify it for our version. And I'll try to explain why I'm doing that as we add in the code here. So let's go through, and actually first we have to add some variables here. So notice in this example, I'm going to increase the size of this a little bit. So it has the same thing here, camera, scene, render, controls. I'm going to move this over closer to my tab so I can go back and forth. So let's scroll up to the top of my script. So it's almost exactly the same. It's not the same order, but it's the same stuff, camera, scene, render, controls. We always are going to have those things in a three.js scene. We're going to ignore this for now. We're covering this next time. Same with this raycaster thing. But here, this looks like something we need, right? We have these Boolean variables, let move forward, let move backward, let move left, let move right, and let can jump. So we need all of those. We're not actually going to do jump today, so actually we can skip that one, but we want all of these. So let's copy those, and we're just going to paste them in here. And I'm going to put a little comment here that says, player movement variables, and then paste this in here. And let's format this up. And so this is the first thing I want to kind of explain is like, why do we have these Booleans? And so we're going to talk about how the movement is going to work a little bit in with our controls. If we look at the example again, basically if I'm holding the W key, I go forward. If I'm holding the S key or the down key, I go backwards. If I'm holding the A key or the left key, I go to the left. If I'm holding the D or the right key, I go to the right. And you can see the movement is smooth. It speeds up and then it slows down. It's kind of subtle, but you might notice that it's happening. And you can also see that I can hold two keys at once, and it kind of does both movements at the same time. If I hold two opposite direction keys, it doesn't move. And so they're not super complicated, but they're doing a lot of different things that make this work in a natural way. And one of the things that we have to account for when we're doing interactive design is, and like games and like pretty much anything that's, interactive, is that we're working with like our computer's frame rate, right? I think we talked about how the animate function, we have this animate function, and it's trying to go 60 frames per second. That's the goal. And if we look at any of these examples, they usually have, this one actually doesn't have it, but a lot of the examples, let's see if we can find one. A lot of examples have like a little FPS meter up here that shows you how fast it's running. And so it's trying to go for 60 frames per second. If you're on a slow computer or it's a particularly heavy example, you may see that meter dip a little bit. This also shows you how many milliseconds it takes to render one frame. And so that is always right around 16 milliseconds, which is how you get 60 frames per second. And it also shows you how much memory your program is taking up. We don't really need to worry about that because we're not doing too much crazy stuff, but it can be important if you're making a big scene. Um, anyway, so we're talking about the FPS. Uh, so the animate frame is going 60 frames per second, and when we move something, you would think that like, if I have my camera here, and here's my floor, and here's like my tree or whatever, you'd think that I just hit the button and I just set, here's let's see, this is the Z position. And let's say Z goes positive this way, Z goes negative this way. And if I hit the arrow key, I just have to set this 0 to 1. And my camera will move forward and it'll, change the perspective and all the rendering will change and stuff like that. But it doesn't work exactly like that. And the reason is because even though we're trying to go 60 frames per second, it's not always going to be perfect because our computer is doing a lot of different stuff at the same time and we're rendering different amounts of stuff. So sometimes our render may take like 10 milliseconds. Sometimes it may take, 15. Sometimes it may take 20. And what the program is going to do is it's going to try to get this as close to 60 frames per second as possible, which is going to be, if we say 1,000 divided by 60, we're going to get some number like 16.6 something something. And so that's kind of like we can't go over 16 and still hit 60 frames per second. So we have to render everything that's happening in the scene in 16 milliseconds or less. And if we go over, then we might compensate on the next frame. So let's say one frame is 17 seconds, we might try to get to 15 on the next frame. So this number of milliseconds is never going to be exactly the same. And so one of the things that we have to account for is when we're calculating how far to move our character or how to animate things. With my duck animation, I'm doing it really, really simply. I have this duck. Let's say this is the tail and this is the head. And I'm going 0.01 or 0.001, something like that, rotation every frame. And so this isn't going to create a very smooth animation because some of these frames are going to take longer than others. This one might be 17 milliseconds. This one might be 15 milliseconds. And so it's going to look kind of choppy. It's not going to look very smooth. What we could do instead, if we were doing something that was more sophisticated, is we can have our character or our camera, we have this camera, and we can say instead of wanting to move, exactly zero point 0.1 units, let's just say units. I don't know exactly what unit it is. Uh, every frame, what we want to do is actually multiply this value by the time that occurred between frames, so between renders. And so if it's 16 milliseconds, we'll get zero point 0.1 times 16 milliseconds, or we'll get 0.1 times 16.5 milliseconds, whatever it is. That's how we get a nice smooth animation that isn't choppy and doesn't break if our program takes a while to render. So that's kind of a long explanation, but that's how most video games and interactive programs are working and what they're dealing with. So that's why we have this other variable here, previous time. We're setting the previous time to performance.now, which is a JavaScript thing that just tells me how long my program has been running for. So if we log performance.now, this really big number represents how many milliseconds the program has been running for. So if I refresh this, I'm going to get a bunch of errors. Crap. Okay, I got to fix this before I can do this example. Let's just take out my controls.update for a second. Okay, so if I try that again, performance dot now you can see that number is smaller and it's just changing. It's just getting bigger every time I'm referencing it. And I can get the change in time of my program using performance.now. And what I'm going to do with this previous time variable is I'm going to compare the time between two frames and then multiply that time by how much I want my camera to move to create smooth movement. There's a few other variables in here that we're gonna grab. Actually, I don't know if we need this one. I think we just need these two. And these are these don't really need to be global variables, but they're just declaring them here just to make it simpler, so they don't get declared every animate. But basically, this is just going to be the velocity of our camera slash player. So movement of camera player, and this is the direction. Um, so we're going to put all these things together, how fast we want them to move, what direction we want them to move in, uh, and the amount of time to get nice smooth movement in our program. Um, we also need a couple things that they didn't put in that I want to be variables. So let's go down and look at this code for a second. So there's a few things here. So there's some hard-coded numbers like this. This is the calculation for the velocity. And so 10 here is kind of like um, sort of like the speed of the character. And then 100 here is sort of like the jump speed. And then down here, there's this value 400, which is sort of also kind of like the move speed in a sense. And I want to be able to tweak all of those. So I'm going to make all of those into variables up here. So I'm going to say constant uh, move. Well, let's just do a generic speed, which is 10, a move speed, which is 400, and then a jump speed, which I forget. Uh, oh no, sorry, this is the wrong one. That's the gravity. Where's the jump? Uh, do, 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 um, velocity.y. Oh, I don't know where the jump is actually. Well, we're not going to do jump today anyway, so we'll come back to this. Um, that's gravity because it's negative. So where does y actually get set? Velocity.y. Huh. Well, we'll come back to it. We don't really need to know this right now. Um, okay. Anyway, so those are our values. Let's just comment this out for now. Okay. So those are our variables. So let's keep going in our script. So we got through our basic variables here and here. So now we can skip to where we actually set up our controls. So we have controls, new pointer lock controls. This section here is doing the thing where when we click on the screen, um, there is that little message that has instructions. And when we click on it, it goes away. We're not going to worry about that. If you wanted to add something like that, you could. It's pretty easy, but that's just doing some stuff with HTML and CSS. We're just going to ignore that today. Um, so down here, this says scene add controls.get object. And this is a little weird because basically the camera is the object of the controls. The controls are moving the camera, so that's why the camera is the first argument for our controls. So the camera doesn't actually get added to the scene by our code up here. The camera actually gets added to the scene down here. I'm not really sure if that makes a huge difference, but let's include that in our version. So what we'll do is just add this down here. So we have controls, three.pointer lock controls, camera, render.dom element, and then we'll say scene.add controls.get object. So this puts the camera actually in the scene. Um, or it may be an object that's connected to the camera. I can't remember. But yeah, that refers to like where the camera is as we move it. So that's pretty simple. Here's the part that now we can spend a little bit more time on. This is what is actually basically getting the user input. So if you remember in P5, or you may have seen this in other JavaScript examples, there's this thing called like mouse pressed or key pressed, where you would get the user input to do different things. Here, we're actually doing this just with using vanilla JavaScript, just from scratch. And so I'm going to write this a little bit differently, but I am going to start with these two functions here. So I'm going to copy those lines. And after I add my controls, I'm going to put these in here, but I'm going to put these as separate functions because I want to be able to edit them separately from the rest of this part. And so basically, what I'm saying here is document. This refers to my browser. And then I'm adding an event listener. So an event listener is just like a little thing on your browser that's just listening anytime I hit a key or press a mouse button or do anything. And so I'm adding a little event listener that's just like constantly looking to see, am I hitting a key? And so I have one for key down and one for key up. So when I hit a key down, I'm going to start moving. And when I lift that key up, now I'll stop moving. And all this really does is it turns these Booleans, move forward, backward, left, and right. It just turns them on and off. That's really all it does. So this is like a very verbose way of writing this, but I think it's pretty clear. So it's a good example. So this is going to add our events. So this is our keyboard events. I guess we don't really need to say there are events. They're just the keyboard events. So add the keyboard events. And I'm going to define these functions over here. If I add more events later, to me, it's just easier to have these functions on the main scope. So I'm going to say on key down, that's going to be a function, and on key up, that's going to be a function. And so all we have to decide in these functions is to say what key did the user hit, and if they hit that key, what do we want to happen? What change are we going to make? You'll also see these things called like key handlers sometimes in different examples. But this is basically just a callback function, like the callback functions we saw with our loading code. So whenever we hit a key, we're going to run this function. And whenever we release that key or whatever key, we're going to call this function. And so in these functions, these are written using switch statements. I'm kind of assuming that you guys have not read switch statements before. They're pretty much the same thing as if-else statements, but they're a little bit, some people prefer them. It kind of depends on what language you came from. They really don't do anything different than an if statement, but I assume that you guys have seen if statements before. So we're just going to go with if statements and not use the switch statement that we see here. But if you've seen switch statements before and you prefer a switch statement, that's fine. But anyway, let's look at what's happening in this code. So we have the on key down function, and we have this thing called the event. So the first thing that we need to do, whoops, where did my program go? So we need our event here. The event is just some information about this particular key event. So let's just log that information first. So this is key down, and this is the event that we got from key down. And let's do the same thing with key up. They look pretty much exactly the same, so we're not going to see anything super interesting here. But let's put event in there. So we don't see that argument here. And that's a thing that's a little bit weird about JavaScript, is that when I have a callback function like this, I can just put the arguments here, but not up here, and it just kind of knows how to find them. But the event is this default argument that we get from the browser. So let's look at what's in that event, and then we'll use it. So I'm going to refresh this page, and I'm just going to hit a key. I'll hit the A key. And so you see the key down event here and the key up. And inside, there's a bunch of different information. So we have the key code. That's probably what we'll use. We have the key just as a key. We have the key code as a number. This tells us whether or not a meta key was being hit, which I think would be the command key. Let's try that. I'm going to hold command and then hit the A key again. And let's see, did that? Yeah, so the meta key is true there. This path actually tells you where the key is kind of focused. So It's the body, then the HTML, then the document, and the window. We don't really need to worry about that. Repeat is false. That means we're not holding the key. So if I hold the key down for a while, eventually it starts to repeat. We don't want to deal with that because it's not very consistent. So we're not going to use that. That's also part of why we're just setting a value to true or false if the key is down. That way we don't have to worry about this inconsistent repeat aspect of the events in the browser. This tells us if the shift key is false. So if you wanted to make the camera or the player run, you could use this shift key here. This is a timestamp. This is the type. So we got a lot of nice information in there. We could actually just use one function and just look at the type, but yeah, so let's use our key code, key A. I like using these numbers because that's how I used to always do it. This stuff is kind of new, but we can see in the example that they're using either arrow up or key W, arrow left, key A. So let's just stick with those for now. So we need to get a reference to the code. Excuse me. So we're going to say constant code is event.code. So that'll give us whatever that key code is. And now we just need a simple if statement. If if code equals, I'm going to use a triple equals here just because that's what most developers tend to prefer. So if the key code equals key A, capital A, and we're actually going to do a compound conditional here. I'm going to do double lines for or. If or the code equals, and we're going to use both the A key and the left key for left movement. So left arrow. And then I have curly brackets. I don't actually need curly brackets here, but I'm going to use them just to make it simpler. I'm going to say move left equals true. That's like all we have to do for this part to make my character move left. And so I'm going to copy this whole thing and paste it in here. And all I'm going to do is change this here to false. So on key up, my character should be moving left. So move left equals true. And on key down. And on key up, same thing, but now I'm switching to false. And so now this is really easy. I can just copy and paste this whole thing 3 more times for the rest of my keys. And so for WASD, so left, let's go move left, move right, move up, move down. So for move right, I want to use the right arrow. And for WASD, I want to use the D key. Oops. For move up, WSD is W, and the arrow is up. And for down, the S key is down, and the down arrow key. And then I'm just going to copy all of these so I don't have to type all this stuff again, and just flip these trues to falses. So it's going to be a while before we actually see this working, but just take my trust me that that's everything that we need to do here. And we can look through this code and see that's pretty much the same thing. So we have a switch statement on this event.code. If it's arrow up or if it's key W, we're going to move forward, et cetera, et cetera, et cetera. And then actually they have the space key, but we'll add that later. Oh, this is where the velocity is. I hate it. I hate that. Anyway, we'll do it like that. That's fine. Anyway, so then on key up, we have all our movement, but there's no jump key here because it's just one jump. Okay, that makes sense. Okay, so we've got our keys, and so we're like pretty close to done. We just have to put in the actual calculations. So those are our events, and so yeah, that's everything we have to do here. Let's close these up for now. And so now we have to do a bunch of stuff in the animate function. So it's actually happening every frame. We're calculating based on what keys are pressed, which direction we want to move. And so here's in our animate function, and this is all in the animate function. I'm again going to take this and put this somewhere else because I like things to be organized. So instead of doing all this stuff here, I'm going to keep this if statement. And I'm going to say if the controls are locked, that means that we've like clicked on the thing. And so our mouse is locked in. If that's true, then we want to update our controls. So I am gonna use this part inside animate. I'll put this where the old controls.update was. But instead of writing all of my movement code here, I'm just going to say movement. I'm going to call a new function called movement update. And I'm going to put that up here. And I'm going to do all of my movement stuff in here. So that way, if I want to update my movement the way it works, I can just go straight here instead of having to sort around where it is in my animate function. So animate's going to call movement update. Everything else will happen in there. And so now let's go through. So this stuff up here, we're going to ignore because we're going to do this. We're going to do this next week. What we do need is this delta here. This is telling us the difference between time. So this is kind of what I was talking about earlier. We need to know how much time has passed since the last time we rendered our scene. Oh, we also need this up here. But this doesn't have to be. Does this even get used? Why does it? I guess you might use this for other stuff, but there's no reason to have this. Okay, so we actually need to start with this. So we need the current time. So constant time equals performance dot now. That's the current time that we're doing this movement update. And then we're getting the change in time. So that's this part right here. And so this is delta. Delta is just a fancy word for change. Actually, if I look this up, it should show us. Um, uh, oh, no, it's not very. Huh, that's funny. That's weird. It doesn't show up in the dictionary. That's weird. Oh, did I not select the whole word? Delta. Okay. Fourth letter in the Greek alphabet, blah, blah, blah. Difference between two things or values. So that's what it means, the difference between two things or values. So that's why we use it when we're writing code to represent the difference between these values. So we're taking the time, the current time, subtracting by the previous time. And we set the previous time when the program started, so all the way back up here. So then we are dividing that by 1,000 to get our value in seconds instead of milliseconds. So let's put a comment here. Current time, difference in time, calculates amount of time since last render in seconds. Okay. So now we're going to use that delta with some other stuff to decide how far to move our character. So here is where we set the velocity of the character. The velocity is speed over time. And so one of the reasons we want to use that is to make smooth movement. So, you know, our velocity will, instead of just like going from 1 to 0, velocity will kind of change over time. So I'm just going to copy and paste these, but I'm going to replace this number 10, which is hard-coded, with my variable for speed that I created. So I'm going to put speed here. And so what's happening here, so if we have, so remember our 3D scene looks like this, where X goes this way, Y goes up, and Z comes at us. So let's imagine we're looking top down, and so this is X, and this is Z. And let's say our camera is like here. So velocity at x is how fast it's moving this way. And what we're doing here is we're actually subtracting, and that isn't significant because we're going to calculate the velocity based on the direction. So don't worry about why it's subtraction. It's the same as addition if it's a negative number, but we're just using subtraction here. So we're subtracting the current velocity of x times the speed times the change in time. So yeah, we're basically just throwing all those values together to figure out, should this be like going a little bit less or should it be going a little bit more, so that it's moving smoothly across the page. So we're putting all those values together. So then the next thing we do is we figure out which way the character wants to be moving. So this right here is doing gravity. We're going to ignore that. This is how we're calculating direction. And this looks a little goofy, so I'll explain what's happening here. So our direction is what direction we want the character to move in. And the velocity, the direction and the velocity are separate because you might be moving in a direction, but you might be kind of like running one way and then you want to switch movement, but you still have some velocity going forward. So we can't just like switch on a dime. What's happening here is a little confusing, but it's written this way. It's actually a nice, elegant way to write this. Basically, we know that move forward and move backward are either true or false. And so what this is doing to make the math easier is converting them to a number. So let's say, for example, let's say we have F and that's true for forward. And let's say we have B for backward and that's false. So a number based on a Boolean is either 0 or 1. So the number for F is 1 and the number for B is 0. And what we're doing is we're just finding out what direction they're going in. So if they're moving forward and they're not moving back, then number of F minus number of B is just going to be, whoops, is going to be 1. Because F is true, B is false, so we have 1 minus 0. That means we're moving forward. If they're both false, if I say number of false minus number of B for backwards, that's 0. So if we're not hitting either button, then we're not moving forward or back. If they're both true, we also get 0. So if we have number of true minus number of true, this is 1 minus 1, so we get 0. Finally, if we have no forward movement, so number of false minus number of true, so we are moving back, now we get a negative 1. So that tells us we want to move backwards. So this is just an elegant way of taking two Booleans and giving us a direction, 1, 0, 0, or 1. Um, so then we're doing that on both directions. We're doing that in the z direction and the x direction, and then we're normalizing this. This is like a little bit tricky, but I'll try to explain what this means quickly. So when we're doing this calculation, uh, so let's imagine we've got x and we've got z, and here's our camera. And let's say we're moving forward +1, and we're moving to the left +1. So the result of this movement would be like this vector, 1 by 1. A vector is just like two numbers that we can do math on. And this 1 by 1, we need to account for this because if we're moving just one direction, then this speed is actually different than if we're moving in two directions because this length is farther than this length. And so when we normalize, what we're basically doing is saying that the vector can't be more than 1. So we're taking this directionality, but we're going to make it short so that the total direction, like the total value of this, is not greater than 1. So that's what normalize means. It means to take like a value but constrain it. And you can constrain it by different things, but the default is to constrain it between 0 and 1. So if we actually said what's the value of this vector that's 1 by 1, it's something weird like 1 point, I don't know, 2 something something. So that's actually faster than how much we should be able to move. So we just cut this off basically. We create like a little circle here that cuts off any values that are greater than that. So hopefully that makes sense. It's just a little nice math to prevent us from moving too fast if we're going in two directions at once. Okay, now we're actually going to apply our direction to our velocity. So I'm going to copy this and paste it in. And this is again is like just a short, elegant way of setting this up. So if we move forward or we move backward, that means we're going to be changing our z velocity. But since we can put them together because we calculated the direction. The direction is either 1 or -1 or some version of that number. So we have direction.z, and then this 400, I'm going to replace this with our variable movement, move speed. And then again, we're always multiplying by the change in time. So same thing here, just have to change our move speed here, times delta. And so now we've calculated our correct velocity based on if we're moving forward, moving back, moving left, or moving right. We're not going to worry about jumping for now. So now we actually use our controls. So I'm just going to copy this. So this is from our pointer lock controls. They have a function that says dot move right, dot move forward, and that's going to take the velocity that we calculated, again, multiplied by the delta, and it's going to move us right or left and forward and back. And we can actually see what this function looks like if we want to go into the original script. I still have it open over here. It's actually not that complicated, but it has some math that we don't want to worry about. So it does this thing where it says set vector from cross matrix and blah, blah, blah. It does all this stuff to make the movement nice and smooth for us. So we have controls.move right, controls.move forward. Um, this is for the Y, we're gonna ignore that. And then, yeah, the last thing we do is we set the prev time to the time. And so that just means that when we get back to the beginning of this movement update in our next version of this prev time will have caught up with where we are in the program. So we're always setting the previous time to the current time after we do our calculations. Okay, so that was kind of a lot, but I think we're basically done. So let's give this a try and see if it works. So if I click on the screen, uh-oh, okay, I must have missed something. There must be something that happens when we click on the screen to enable this. Let's go back up. Okay, controls.lock. Let's see. So we do need to use this. Where's the unlock function? I don't see that in here. Okay, let's just write this real quick. So I'm just gonna put this um, on the renderer instead of the instructions because I don't want to deal with making the instructions right now. So I'm just gonna copy this and let's go back up to our init function. And so after we set up our controls, so what this is doing is it has this instruction thing. I'm going to replace this with our DOM element on our renderer so we can just click directly on the canvas for now. So when we click on the canvas, it's just going to lock the controls so we can start moving. So let's refresh and okay. So now I can move left and right, and I can move with the camera with my mouse. I can't move forward or back, so I must have missed something. But I am moving left and right. Let's see if I can figure out what I missed with the forward and back. But I can kind of get over here. Here we go. Okay, so that's kind of fun. I can come sit next to my duck. And, oh, I didn't put in, oh, okay. So it must be built in when I hit escape, it unlocks the control. So that must be built in. So let's see if I missed anything obvious with my left and right. So I have move left, key A, left arrow, right arrow. Let's see if that arrow up. Oh, I did this wrong. Arrow comes first. Whoops. That's why I like to use codes because the numbers are easier to remember than the way they do this. Arrow left, arrow right, arrow up, arrow down. Okay. Key W, key A, key S, key D, key A, key D, key W. Those are all right. Same thing here. Arrow left, arrow right. All right, let's see now. Okay, I still can't move left and right, so there's something else happening with the code. Let's see. Don't need any of this stuff. Let's see, what did I miss? Movement update. Okay, current time, delta time, X, Z, Z. Direction Z, number move forward minus number move backward. Is that the same? Yes. Direction X, number move right minus number move left. Direction dot normalize. Move forward or move backwards. Velocity dot Z. Da, 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 da. Is it the move speed? No, because it's being applied to both. Move speed times delta. Maybe we actually need this to be in here for some reason. So this says if on object, so that means we're standing on something. So let's assume we're standing on something. I'm just going to put this in here by itself for now. See if that changes something. No, I can still only move right and left. Okay. So let's also throw this in. It doesn't actually say what this is, it just says new behavior. So this says controls.getObject position.y plus equals velocity.y times delta. This is just jump, so it shouldn't affect right and left. Okay. Well, I don't know. I'm not seeing anything that I'm missing here. Move forward, velocity.x. So I'll have to debug this a little bit and figure out what I missed, but it shouldn't take me too long. And yeah, that's basically what we want to do. Uh, so yeah, we'll add in, next time we'll add in what's called ray casting. And this is basically just a way of figuring out if we're standing on something or not. And so if we're standing on something, we'll be able to jump. And if we're not standing on something, we'll fall. And so we'll make a very simple version of gravity that way. But yeah, that's what we're working on for today. I'll share this with you guys so you can remix this or copy the code into your project or however you want to work on it. I might keep debugging this for a second and just keep on the recording, just so that'll be on there. But if you guys want to ignore me and start working on your project, you're welcome to do that. But yeah, do you guys have are there any questions or anything you want to go over again? Okay, cool. So yeah, I'm gonna figure out what the issue is with the forward and back movement, and I'll update you guys once I do. Otherwise, you guys can just work on your project. And if there's other stuff in three.js that you want to add in, just send it to me, and I can try to work it into one of the demos. So yeah, let me see if I can debug this real quick. Oh, I just wrote the variables wrong. It's not move up and move down, it's move forward, move back. So I was just naming the variables incorrectly. Okay, there we go. Uh-oh. Okay, I can move forward, but I can't move back. Move forward, move back, move forward, move back. What is it called? Move backward. Such a long variable name. Okay, now I can go forward and backward. I can come sit next to my duck and hang out. Um, Cool. One last thing, if you were paying attention, which I think is cool, I was just doing some debugging, but it's good to kind of look at this. So let's log the velocity so we can actually see what's happening here. And so you'll see what I mean by smooth movement. So right now you can see the velocity is 0, 0, 0 for x, y, and z. And as if I move forward, notice that the values change. Um, it's a very small value, so I'm not moving, but you can see that Z value. So you can see as I move forward, the Z value gets really big, but then it slowly gets smaller. And it's a subtle effect, but there's this little slide that happens as I move that's happening because I'm using velocity and I'm using change in time instead of just like basically doing what the duck animation is doing, which is just moving one frame in a second. And it looks fine because the frame rate is good on this computer. But if the frame rate was a little bit slower, it would look choppy. But yeah, so you can see those velocity values. If I go to the right, so it kind of tops out x is negative 39. And then it's only a few frames, but it slowly goes back to 0 instead of just going to 0 immediately. So I get this little nice smooth transition from moving to standing still. Anyway, just wanted to show that real quick. I'm going to shut up and I'll stop recording, and you guys can work on your projects.